This problem, just the language gives away the structure. So it tells us we've got a perpetuity. So we're looking for a constant cash amount that's paid every year forever. And so here that constant cash amount is 1018. There we see it going on forever. But there's a catch with this with this problem. The first cash flow doesn't occur in year one as it conventionally does with a perpetuity. When does it happen? It happens 3 years from today. And so here's what the timeline looks like in this case. All right, so like I said, this is a perpetuity, but its structure is slightly different than what we are used to. So we've got our formula for finding the present value of a perpetuity, and that's just PV equals the cash flow divided by the discount rate. But in our traditional way of doing things, this is at time 0 and this is at time 1. 0 and 1. Or more generally, this first cash flow is 1 period after the PV is true. And so what that tells us is that this formula could apply if PV was 1 and C was 2, or if PV was 2 and C was 3. The point is these are going to happen 1 period apart. All right, so what does that mean for the problem at hand? Well, it means that the perpetuity formula is going to apply, but it's only going to apply in a first step, and there's going to be more that we need to do. And so ultimately here, we are after what? We're after a present value at time 0. So we need PV at time 0. So we need to go to right here. Okay. Well, let's see what we can do on the front end. So we've got this formula here. So we notice immediately that the first cash flow doesn't happen until time 3. So that's a 3. Okay, so this PV then, if we want to subscript the PV, we need to subscript it with 1 period prior to that first cash flow. So this is a PV at time 2. If we do a present value of a perpetuity calculation, that's only going to get us to right here. Okay, so let's go ahead and do that. So we have 1018 divided by 3%. That gives us 33,933, and we'll carry this out to 4 decimal places so we don't mess ourselves up too much with rounding. Okay, so this is an intermediate step. Okay, so what can we do with this 33,933.3333? Well, we can put it on the timeline right here. So I'm going to write it there. So 33,933.3333. In this initial step, we have swapped this amount at time 2 for this perpetuity. Okay, so we've swapped them. It's the present value as of time 2 of the remaining perpetuity. And so as we move forward then, we can proceed as if that's no longer part of the timeline, and our timeline now only has one single number on it, and it is at time 2. Okay, so now we can move on to our next step. Our next step then is essentially calculating the present value of a single cash flow. So we've just got to bring this number back to time 0 or discount it by 2 periods. And so our PV at time 0 now is 33,933.333 divided by 1 plus the discount rate. And what's our exponent now? It's a 2, right? Because we're going back 2 periods. We're going back 2 periods right here. So that needs to be a 2. So this is 31,985.4212. So there is the final answer. So that is our PV at time 0.